In operations, safety is absolute necessity. Every decision, especially maintenance decisions, must uphold the highest standards of reliability, readiness, and assurance. Plants manage large inventories of equipment, each with different safety roles, reliability importance, and consequences of failure. The challenge teams face every day is not deciding whether to maintain the equipment, but which components must receive the attention first. So here comes the maintenance priority intelligence, which brings clarity and structure to this challenge. It evaluates nuclear equipment using internally defined risk and critically attributes and uses Copilot with clear explanations. This ensures maintenance prioritization is consistent, defensible, and aligned with nuclear safety principles. So we begin by defining the objective in the AI first designer, the planner, where it is clearly defined. Let us input the objective here and then generate the plan. See, it's getting generated. Let's wait for it. First, the clear business problem is which we have input is defined here, creating an application that evaluates nuclear premium maintenance needs and all. Then the purpose of this plan is being defined. Then comes the users who are going to use application and for what purpose. That is an important aspect of this application. So here comes the maintenance lead, the person responsible for planning and overseeing equipment maintenance activities, which this app will definitely help them in reviewing a ranked maintenance priority list, view the transparent explanation for each priority ranking, adjust the maintenance plans, track high priority items, and so on. Next comes the safety engineer, who is accountable for ensuring maintenance decisions align with nuclear safety and ethics, who reviews the safety and reliability indicators for each equipment items and also evaluate the consistency of the ranking logic. He accesses the Copilot generated explanation for each priority. So here comes the use of the Copilot. Then comes the monitoring trends in priority stability. Next is the supervisor, who is the person manage execution and discipline of maintenance teams. As a user, he view compliance and completion trends for high priority items, get quick pre-job and pre-outage reviews, receive notification and a summary of maintenance status. So all looks good. Let's move on to generate the set of processes which actually helps in solving the business problem. Wait for it. See, the user processes have been defined, which helps in solving the business problem. First is define the maintenance prioritization scope and framework, which establishes the foundation for maintenance priority by defining objectives, target users, prioritization horizon, and so on. Next is the equipment and risk data setup, which involves capturing and structuring all relevant equipment and risk data, including safety classification and reliability importance. The goal is to ensure all the inputs are internally defined, consistent, and defensible. Next is the priority evaluation and ranking, which defines and applies the weighted logic to evaluate and rank equipment maintenance needs. Next comes the Copilot layer, which will enable to access the human readable explanation for each maintenance priority. Supports training, audits, and leadership reviews as well. The last one is the maintenance execution, oversight, and assurance. This tracks the execution of maintenance activities against priorities, monitors the compliance and backlog trends, and provides visibility into repeated deferrals and operational discipline. All looks good. Next, the data model is being set up, which will define the different tables which are actually maintained in the dataverse. So, and the relationships are also established between those tables in the data model. Looks good. Next is the technology which will actually be used to solve the business problem, the platform on which all these will be defined. So the first one here is the maintenance priority planner, which is a model driven app which enables leads, safety engineers and the supervisor to view, manage and track the maintenance priorities. Next is the priority explanation co-pilot, the center of this whole solution, which will help in supporting the leads, safety engineer and supervisors by explaining the equipment ranking, reasoning and the changes for transparency, training and audits. Next is a automation flow for the priority alert, which will notify the supervisor when high priority maintaining tasks are repeatedly deferred. These automations all run in the background and make sure everything is in sync. Priority compliance dashboard for the safety engineers and supervisors to monitor trends. Looks good. Next, we can also have a look at the data model which has been generated. As has been told earlier, the tables and the relation between the tables are established here. We can also add new tables and remove tables and change as and when required, but for this purpose we don't need to. Okay, thing looks good. We can have a look at the process flow as well. Here is the whole process flow where the business problem is defined and for whom are these set of application being developed, the user roles and the components as well is mentioned over here. We can have a look here. We can see if it all are relevant, we can change it, we can do whatever we want to, but for now we are not going to do anything. It all looks good. Yes. Okay. So in this part, let's have a look at maintenance priority planner app, which enables leads, safety engineers and supervisors to view, manage and track ranked maintenance priorities with safety critical visibility and compliance monitoring. We can see the different areas whose details are captured here and which is really useful for them. First is the active equipment and the inactive equipment details with the equipment name, area, classification, safety classification for these equipments, the reliability importance, all the details are stored here. Then comes the maintenance priorities for these equipments, which needs to be maintained first. The ranking is given based on the priority index, which are calculated using the priority scoring rules. You can see here equipment reactor core pump has a priority index of 95.5. So it means immediate action. While emergency generator has an index of 75, so it doesn't need immediate action. It can be waited. It can wait. Next is the priority scoring rules, which the rules are defined for calculating the ranks for the maintenance, which has to be done first. Depending on the high weight for consequence, ensure repeatable ranking logic, or a lot of other things are taken into consideration. Then comes the maintenance status report, which tracks the active maintenance status trackings as well as the inactive maintenance status trackings for the different equipments, which gives the equipment name, the high priority address, the priority stability score, repeated deferrals. Everything is shown here at one go. And these are calculated using the copilot, which runs at the back, and all are in sync or updated using different automation flows. Let's have a look at the priority explanation copilot, which supports the leads, safety engineers and supervisors by explaining equipment ranking, reasoning and priority changes for transparency, training, and audit purpose. We can see the different instructions given and the dataverse table, which is the knowledge source for this agent. As we can see here, testing a agent, a scenario was given to the agent, ongoing priority list of equipments. So it has given us the list of ongoing priority list of equipment. Priority 1, that is immediate action for reactor core pump. Priority 2 for pressure vessel, then emergency generator, then control rod, and then cooling tower fan. And the explanation for these ranking is also given because they are based on combination of consequence, that is impact if failure occurs, reliability and safety considerations. So this ensures that resources are focused on equipment which are critical and they need to be taken care first. Next is we want to know the priority indices for these equipment. Let's see. And this agent has generated the following indices. For cooling tower fan, it is 45. All these, as we have seen earlier, are generated using the rules which has been defined. And we can also see the summary of priority changes for the audit purpose and who has generated it. Each and every detail is given here. As we can see, the results from the copilots can be linked to the console via automations so that all are in sync. These summaries can be generated at the console level also, which calls the copilot at the back end. And we are here having a look at the explanation copilot. So we can see how useful it is for the nuclear energy sector. Thank you.